Kubernetes and GKE Part 15. This episode has 5 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. What is a job in Kubernetes? Here's a strong way to approach it. A job in Kubernetes is a controller that runs a pod to completion and ensures it successfully finishes its task. Core idea: a job is used for finite, one-time workloads. Run this task, complete it successfully, and then stop. Unlike deployments, which run continuously, jobs are not long-running services. How it works: creates one or more pods, ensures the pods run until completion. Exit 0. If a pod fails, it is retried automatically once successful. Job is marked as completed. Types of jobs: 1. Simple job runs a task once and completes. Example: database migration. 2. Parallel job runs multiple pods in parallel. Example: processing large datasets. 3. Job with completions runs a fixed number of successful completions. 4. Cron job. Related concept. Schedules jobs periodically, like cron in Linux. Common use cases: database migrations, batch processing, ETL pipelines, backup operations, one-time scripts. Key properties: restart policy is important, usually on failure. Supports retries via backoff limit. Tracks success using pod. Exit status: job versus deployment. Feature: job deployment purpose: run to completion task. Long-running service life cycle: finite continuous restart until success. Always running. Example: backup script. Web server. Interview ready. Definition: a Kubernetes job ensures that a specified number of pods successfully complete a task, automatically retrying failed pods until the desired completion count is reached, and then terminates. Nice. Let's continue. Question 2. Explain cron jobs. Here's a strong way to approach it. A cron job in Kubernetes is a controller that runs jobs on a scheduled time basis, similar to the Linux cron utility. Core idea: a cron job is used when you want to run a task repeatedly at fixed times or intervals. Instead of running once, like a job, it runs periodically. How it works: cron job creates a job at scheduled times. That job then creates one or more pods. Pods run the task to completion. After completion, they terminate automatically. Schedule format: cron jobs use standard cron syntax. Day of week: 0-6. Month: 1-12. Day of month: 1-31. Hour: 0-23. Minute: 0-59. Example: schedules or 5 every 5 minutes, 02 every day at 2 a.m., 000 every Sunday at midnight. Common use cases: database backups, log cleanup, report generation, sending scheduled emails or notifications, batch ETL pipelines. Important features: concurrency control, prevent overlapping runs, allow, default, forbid, skip if previous run is active, replace, kill old and start new. History limits: successful jobs history limit, failed jobs history limit, starting deadline seconds. Defines how late a missed job can start. Cron job versus deployment. Feature: cron job. Job deployment type: scheduled task, one-time task. Continuous service: runs repeatedly once. Always controller creates jobs. Pods. Interview ready. Definition: a cron job in Kubernetes is a controller that schedules jobs to run at specific times or intervals using cron syntax, enabling automated recurring tasks such as backups, reports, and batch processing. Great. Moving on. Question 3. What is Kubernetes? Here's a strong way to approach it. The Kubernetes is the central management component of Kubernetes that acts as the front door of the Kubernetes control plane. Core idea: every request in Kubernetes goes through the API server. Whether you use Kubectl, UI tools, or controllers, everything talks to the Kubernetes. What it does: the Kubernetes is responsible for 1. API request handling, accepts REST requests, create pods, deployments, services, etc. Serves as the only entry point to the cluster. 2. Authentication and authorization, authenticates users, certs, tokens, OIDC, checks permissions using RBAC or ABAC policies. 3. Validation, ensures requests are valid before storing, rejects malformed or unauthorized objects. 4. Data storage, interface reads or writes cluster state to ETP, key value store. 5. Communication hub, all other control plane components talk to it. Scheduler, controller, manager, kubelets. Architecture: role in the Kubernetes control plane. Kubernetes brains, front desk, ETP, memory store. Scheduler decides where pods run. Controller manager maintains desired state. Request flow: example, when you run Kubectl, create deployment and Ginks flow. 1. Kubectl sends request to Kubernetes server. 2. API server validates it. 3. Stores object in et. 4. Scheduler notices new pod requirement. 5. Pod gets assigned to a node. Key characteristics stateless. Can run multiple replicas. Horizontally scalable. Exposes REST API. Highly available in production clusters. Interview ready. Definition: the Kubernetes server is the central control plane component in Kubernetes that exposes the Kubernetes API, handles all client requests, performs authentication and validation, and serves as the gateway for reading and writing cluster state to et. Alright, next question. Question 4. Explain et. Here's a strong way to approach it. Et is the distributed key value store used by Kubernetes to store all cluster state and configuration data. Core idea: et is the source of truth for the entire Kubernetes cluster. If data is in et, Kubernetes considers it the current desired plus actual state of the cluster. What it stores: et holds all critical cluster information, such as cluster configuration, node information, pod definitions and status, deployments, services, config map secrets, encrypted at rest in production setups. How Kubernetes uses et. The Kubernetes server is the only component that directly talks to et. Flow example: 1. User creates a deployment via API. 2. API server validates it. 3. Data is stored in et. 4. Scheduler plus controllers read from et via API server. 5. Cluster state is continuously reconciled. Key properties of et. 1. Distributed runs as a cluster, usually 3, 5, or 7 nodes. Prevents single point of failure. 2. Strong consistency. Uses RAF consensus algorithm. Ensures all nodes agree on data. 3. Highly available. Survives node failures as long as quorum exists. 4. Fast key value store. Optimized for read or write of small metadata, not large files. Why Kubernetes uses et? Because it needs reliable state storage, consistency across cluster, high availability, fast read or write for control plane decisions. Example of stored data: simplified, or registry, or pods, or default, or nginx pod spec plus status, or registry, or nodes, or node 1 node metadata, or registry, or deployments, or default, or web deployment spec. Important concept: quorum in a 3-node et cluster. At least 2 must be alive. Prevents split brain situations. Failure impact: if et is down, Kubernetes cannot create, update, or delete resources. Existing workloads may keep running, but cluster becomes unmanageable. Interview ready. Definition: et is a distributed, strongly consistent key value store used by Kubernetes to store all cluster state and configuration data, and it serves as the single source of truth for the entire cluster. Let's keep going. Question 5. What is Kubescheduler? Here's a strong way to approach it. The Kubescheduler is a core component of Kubernetes that is responsible for deciding which node a newly created pod should run on. Core idea: the scheduler does not run pods, it only decides where they should run. It takes unscheduled pods and assigns them to the most suitable node. How it works: high-level flow. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.